what would you do to solve that simple equation right there? You would divide, because dividing is the opposite of multiply. What would you do to solve this equation right here? Subtract, because subtraction is the opposite of adding. What would you do to solve this one? Because adding is the opposite of subtraction. So, also, what would you do to solve this equation right here? The opposite of a square is a square root. So we always do the opposite operation to solve. So what we're going to learn today is what is the opposite of an exponential. Now, the kind of exponentials that you were solving on your green homework paper, the bases could match. But this can't be put in base 5. There's no base 5 that's equal to 50. So we need another way to solve it, and the way we're going to solve it is by doing the opposite of an exponential. And the opposite of an exponential is called a logarithmic function. Except we usually don't call it that. We usually just abbreviate it and call it a log function. And the log function is the inverse of an exponential. Do you remember what an inverse is? You switch the x and the y. And so that's what it's trying to show you on the graph paper here. This is an exponential graph. This is the kind of graph that's going to be on the test on Thursday. And then we'll take this graph and move it up and down and left and right. This graph right here, growth or decay? Growth, because it's getting bigger. And so then I think they've already done it for you. They've taken the points on this graph and they've switched the x and the y to get this table right here. So would you take these points right here and put it on your graph paper, please? Does your graph look something like this? Now, this graph, this table stops right here, but the graph does not, because I can't have room to make an infinite table right there. This is going to keep going, and it's going to get closer and closer and closer to the axis. What do we call it when it gets closer and closer and closer and doesn't ever touch? Asymptote is right here. This red dotted line that goes through the middle here is the line y equals x. If you folded it on this line, the exponential and the logarithm graphs would match. That was one of our definitions of an inverse. If you have an inverse and you switch the x and the y, then the domain and the range switch. If you switch the x and the y equals asymptote becomes an x equals asymptote. So please fill this chart in on your notes. So all we are going to do, if you turn the page over, you will find way more writing than we usually give in your notes. This gives you a little bit of information about the mathematicians that came up with this idea of a log or logarithm. And it also tells you some of the uses for a logarithm. I would think most of you have already used a logarithm scale because most of you have already taken chemistry and you have done pH in chemistry, right? What does pH measure? I won't tell your science teachers that you've forgotten already. pH measures how much the solution, how acid the solution is. You remember having a pH scale that measures the acid, and a 7 on the scale means it's neutral? Have we had chemistry? Okay. Another very common use of a logarithm scale, I've been very surprised not very many of my students have known what a Richter scale is. Do you know what a Richter scale? It measures the amount of an earthquake. And so we had an earthquake that measured 2 on the scale, it would shake you up in your chair. If we had an earthquake that measured 4 on the scale, it might knock you out of your chair if you weren't holding on. But that's only 2 times bigger, right? 2 to 4, 2 times bigger? No, because it's a logarithm scale and the base is 10. It's 10 to the 2nd power compared to 10 to the 4th power. It's 100 times bigger. Even though the number only increases by 2, the magnitude of energy that's released increases by 100. And so a logarithm scale focuses on the exponent. Another very often used logarithm scale that you may be familiar with is decibels. Does anybody, not decimals, decibels. Does anybody know what a decibel measures? Sound. And so, but that is based on a logarithm scale. So some of you have the decibels going into your ears way too high, and that is injuring your ears. And so we are just going to follow the definition to change from exponential to log and from log to exponential. That's all we're going to do to get started. Change from exponential to log and log to exponential, and we're going to do that by just following the rule. This is going to be hard for some of you because you're not very good at following rules. So, would you please write the rule down at the top of the next page, or right there by example number 1, and all we're going to do is follow the rule. So, to change from an exponential to a log, I'm going to have the word log, and the base of the exponent is also the base of the log. So, what's the base here? This 3 is a subscript. It's little and down a little bit. And then the exponent, what's the exponent here? That's what the log is equal to. And then the 9 goes here. And you say that log base 3 of 9 equals 2. Log base 3 of 9 equals 2. It's just following the rule. That's all it is. Let me also point out that on your scientific calculator there on your desk, it has a log button. You cannot use it on this problem, because on the calculator it is log base 10. The only thing I can use the calculator for is log base 10 or log base E, and we aren't even going to talk about log base E. They're going to do that next year pre-cal. And so you cannot do a log base 3. You can't put in log of 9 in your calculator and it tells you the answer's 2, because your calculator is based on 10, because 10 is the common logarithm. It's the most commonly used logarithm in science. And so that's why there's a base 10 in your calculator. So all I'm doing is changing from one form to the other. So to change it to log, I start with the word log, and then next comes the base. What's the base? The base of the exponent. Equal to the exponent, and the 1 over 16 goes there. So if it's a fraction, we usually put a parenthesis around it. We would say log of 4, log base 4 of 1/16 equals -2. I'm not asking you whether this is true or false. It is true, by the way. We're just changing from one form to another. Not solving for anything yet, but we're going to be able to use this to solve our equations. If it's in log form, how do I change it back into exponential form? Well, here's the base. This is the exponent, and it's equal to the 25. And of course, we would know that that is true. 5 squared does equal 25. This is the base. This is the exponent. And it's equal to this number right there. Some people are helped by drawing that little circle. This is the base. This is the exponent. That's what it's equal to. And this is the kind of problem we may solve coming up. And so we could look at our chart that I had up here on the board previously, and we could see that 81 is 3 to the 4th power. So 3 to the 4th power would be equal to 81. X is equal to 3. That's what we will be doing when we start solving these. But right now, we're just changing from one form to the other. So this is base 2, and that's the exponent. And then it's equal to the y. That's all we're doing, changing from one form to another.